In this video, we look at X-value bugs in digital circuit design. X can represent an uninitialized state, uncertainty, or a conflict in multiple driver situations. The X value doesn't physically exist in real hardware. The simulation tools interpret X as unknown logic, but the synthesis tools interpret X as a don't care value. So the synthesis tools try to optimize the circuit. X can indicate several types of bugs that might cause issues in your actual hardware. In the next slides, we look at different situations that the X value introduce bugs. First, uninitialized registers. So in this example, if there is a rising edge of the clock and enable signal is low, the Q signal keep its previous value. So as you can see, there is no else, and also there is no reset logic. So in simulation, the Q value receive the X, but in synthesis and real hardware, the Q power up with a random value, which can be 0 or 1. So this code introduce mismatch between synthesis and simulation, which is not appropriate. Next, incomplete case statements. For example, in this combinational block, if the value of the cell is 1, 1, the output doesn't receive any value. In simulation, it introduces the output get the X value. But in synthesis, maybe the latch is introduced, which is not intended, and also it causes mismatch between simulation and synthesis. Next, cross-clock domain issues. So in this example, signal A is in clock domain A, but we sample signal A with clock B. So the captured clock may become X because of the meta-stability. The solution to this problem is use a synchronizer to synchronize the signal A with clock B. Signal conflict or multiple drivers. So in this example, the signal bus can receive the value 1 and value 2 if both condition and other condition are correct. Again, in simulation, it introduces the X value, and in synthesis and real hardware, it gets a random value. Out of range array indexing. So in this example, the memory is 8-bit and it can has 16 addresses. So, but in this line, we introduce addresses as the 5-bit. So addresses can be between 0 and 31. In the next line, if the address is more than 50, the data receive X value. Again, it's mismatch between simulation and real hardware, because in real hardware, the data value is unknown. Incomplete conditional assignment. So in this combinational block, if condition 1 is false and also condition 2 is false, the output signal doesn't receive any value. So in simulation, the output signal become X, but in synthesis, maybe it introduces latches, which is not a good behavior. And the last one, X optimist in simulation versus reality. In this piece of code, there is two bugs. First, it uses case equality. Case equality shouldn't be used in RTL modeling. And the next one is it compares the control signal with the X value. So maybe this piece of code works correctly in simulation, but in synthesis, it considers this line as don't care, and probably it remove this part and it only produce circuit for this line of the code. So we have mismatch between simulation and the real hardware.